Hi, I'm Thi Quach, and today I'm going to teach you Intro to Arithmetic Sequences. Arithmetic sequences are sequences where the number has a consistent difference by either subtracting or adding. There are two ways of showing arithmetic sequences. The first one is the explicit formula, which is n is equal to 1, and it can go all the way up to infinity, with an equals am plus n minus 1d. An is what we are looking for. Am is the first number in the sequence, plus n is the term that we are looking for, minus 1 times d. D is the difference between the numbers in the sequence. We can also write arithmetic sequences recursively. A1 equals m. M is the first number in the sequence. An equals an minus 1 plus d for n is greater to or equal to 2. D is the difference between the numbers in the sequence. For our first example, the sequence is -3, 0, 3, 6, and 9. We can tell that from -3 to 0 is adding 3, 0, 3 is adding 3, and it continues on. So this is an arithmetic sequence. So we can write this in the explicit formula by n equals to 1, goes all the way up to infinity, with an equals -3 plus n minus 1 d. D is 3, and we can rewrite that to -3 plus n minus 1. So the 3 is in front of the parentheses. We can also write this recursively. A1 is equals to -3 since -3 is the first term. An equals to n minus 1 plus 3 for n is greater or equal to 2. It's plus 3 because 3 is the difference. Our next example is -15, -23, -31, and -39. There is a difference of -8 between all of those numbers, which shows that it is arithmetic. We can write this in the explicit formula by n equals to 1 goes all the way up to infinity, with an equals to -15 plus n minus 1 times -8. We can rewrite that to -15 plus 8 times n minus 1. And we can write this in recursively by a1 equals -15. An is equal to an minus 1 minus 8 for n is greater or equal to 2. Our next example is 6, 12, 24, and 48. You can get to 12 by adding 6, 24 by adding 12, and 48 by adding 24, which shows that this is not an arithmetic formula and rather a geometric sequence.